Hello there. So we'll continue with this first topic about the introduction on materials. So we reached this slide, classification of materials. So materials could be classified into different categories, if you want, depending on their physical state and their chemical state as well. So based on their physical state, materials could be in state of solid material or liquid or gas. In terms of chemical classifications, so you can find two main categories: pure substance and the mixture one. So what's the difference between pure and the mixture? Of course, pure is not mixed with any other element. So for pure substance, you could also find element and compound. So element is formed by only one element, but a compound is a mixture of two. But still, we call it a pure substance. Example of element, let's say you have hydrogen, oxygen, nitrogen, and so on, as many other examples of pure substance that is formed by one single element. Or you could have a pure substance, but in a form of compounds like water or sand. So, of course, water, you know, it is formed by hydrogen and oxygen, of course, H2O. So this is water, of course. So it looks like pure substance, but in fact it is a compound one. It is formed by hydrogen, two molecules of hydrogen and one molecule of oxygen. But when you look at the material itself, it looks like a pure one. Also sand. If you look at the sand, so while sand is formed by, of course, different minerals like silica, and mostly is dominated by silica. It depends on the type of sand, but most of the sand are siliceous sand, which is formed by silica, SaO2. But you can find, of course, other minor elements. So this is why sand, it is one compound, but it is at the same time, it is pure substance, classified as pure substance. So the second category is a mixture of compound. A mixture could be also in homogeneous or heterogeneous state. So homogeneous state, like air. So when you look to the air, of course, you cannot distinguish between the different components. But air, it has CO2, oxygen, it has some other types of nitrogen, some other types of gases that are available in the air, but you cannot distinguish between these different components of the air. Also, if you pure salt in water, or even sugar also in water, so of course salt will be dissolved in water. So it is a mixture, of course, of salt plus water, NaCl plus H2O, but it is a homogeneous mixture because you cannot distinguish, as a mixture, you cannot distinguish between the salt and the water once it is dissolved in the water. So this is why it is classified as a homogeneous mixture. It is a mixture, but it is homogeneous because you cannot distinguish between the two phases: the phase of solid salt and the phase of the liquid, which is the water. But at the same time, you can find another mixture which is in heterogeneous state. So like sand and common salt, if you have a mixture of salt or sleet or silt or clay mixed with sand, so it is a mixture, but of course you can distinguish between the sand, which is dominated by the silica, siliceous sand, and the salt or the silt or the clay. So in that case, it is classified as heterogeneous mixture. So also the pure substance in a form of compound, it could be organic or it could be inorganic. So also two different classifications for the same compound. So this is in terms of chemical classification. Now we just go back for the physical classifications and we will see some properties of the materials in a physical state. So we said that physical state could be divided, or material could be found in solid or liquid or gas state. So this is in terms of the physical state, but also in terms of properties, they will be different. Properties of the material, let's say the same material in solid state or liquid state or gas state, they have different properties. Solid state of the material, usually it is characterized by a rigid property. So it is quite hard and rigid. You cannot squash it, you cannot squeeze it. Also the shape, it is a fixed shape. If you have a cube or a cylinder or a rectangle or whatever, so the shape of solid material, it is fixed. It does not change, unless of course you exert or you apply, a force or a stress or whatever. Also the volume is fixed. If you have, I don't know, 1 meter cube or a half meter cube of this solid material, so the volume stays the same, it does not change. If you put it in another container or another mold or whatever. However, if you look at the liquid state of the material, so of course liquid is not rigid, it's not hard. So you can easily, of course, penetrate any solid material or your finger or whatever. So whether this liquid is water or oil or whatever, so as long as it is in the liquid state, so it is characterized by a soft quality. Also the shape is not fixed. So the liquid material will take the shape of the container. If you put it in a cylinder, it will take the shape of cylinder. If you put it in a shape of cube, it will take the shape of cube. If you put it in another shape, complex shape, so it will take that specific shape. So it does not have a fixed shape like the case of solid material. But the volume is, of course, fixed. So the shape is not fixed, but the volume is fixed. So if you have 1 liter here, whether you put it in a cylinder or a cube or a bottle or I don't know, or a rectangle or whatever, the volume stays exactly the same, fixed volume. So you can see here between solid and liquid, you have opposite properties, unless or only the volume which is the same. It is fixed either in a solid state or in a liquid state. If we come to the gas, of course, also it is not rigid, so it is similar to the liquid. Also, the shape is not fixed. It takes the shape of the container or the mold, but also the specificity of the gas compared to both liquid and solid. So it has no fixed volume. The volume changes depending on the state of the gas, depending on the conditions of the gas, depending on the container. So it can be squished, can be squeezed. So these are the three different states, physical states of the materials. But nowadays we have a fourth state. Can you guess which state we are talking about? So we have a new state of, or new physical state of the material. So it is called the plasma. I think now you realize what I'm talking about. Most of you may have a TV, plasma TV in your home. So this is a new state of the material. So what makes a plasma, or even what makes the material changing from solid to liquid to gas to even plasma? So it is always the heat. So it is the heat which makes the material changing its physical state. So if you have solid material, by heating, you can transform it into a liquid material. Of course, the temperature is different from one solid to another solid, but the principle is the heat, thermal treatment, or burning the material, or calcining the material, or exerting heat on the material will change its physical state. Also, the liquid material, if you heat it up, so it may transform into a gas. And lastly, the gas, if it is heated up to a higher temperature, of course, it will be transformed into a plasma. So you can see the energy, more you put energy, more you change the state or the physical state of the material. And you can just take the very simple example, the basic example, water. Water is liquid at the temperature over zero. If you heat it up to above 100 degrees Celsius, so it will be transformed into a gas. But if you freeze it to a temperature, or you expose it to a temperature below zero, it will be transformed into an ice, which is a solid material. So same material could have three different states, depending on the temperature it is exposed to. So it is always a matter of heat and a matter of energy by which you can transform the material from one state to another state. And same thing. So it's a reversible phenomenon. So if the material is in a liquid state, so by freezing you transform it into a solid state. If it is in solid state as an ice, by heating up, you melt it and you transform it again into a liquid state. So also last thing to mention about the solid materials before we move forward. So solid material could also be in two states or two different categories. It could be organic material or it could be inorganic material. Organic material, like for solid material, it could be polymers or wood, or to be more accurate, it could be just a polymer. And the polymer could be natural polymer, which is wood, or it could be manufactured polymer, which is plastic polymer. So this is the organic state. Organic because it has carbon in its composition, or it could be in inorganic state or inorganic composition. And this case is mostly for, of course, metals because they are not organic materials. They are composed of metallic element. And for glass and ceramic materials, they are also non-organic materials. Now also for the physical classification of materials, solid materials, we have seen solid, liquid, gas, and plasma. So this is in terms of physical state of the material, but also we have classifications based on the morphological structure, whether this structure is crystalline or a non-crystalline structure. So we have two different structures. That is not only for, of course, for solid materials. For liquid, we don't have this kind of classifications. So this classification, crystalline or non-crystalline, is only exclusive to solid materials. So what is the difference between crystalline and non-crystalline? Of course, you can see the arrangement of atoms, how the atoms are arranged. So it is well arranged here, well structured, but in a non-crystalline, which is also called amorphous or glassy. So you can see here the atoms in the structure are randomly arranged, are not ordered. So here it's an ordered arrangement, and here it is a disordered or a random arrangement of atoms. We have of course many examples of crystalline and non-crystalline materials, but just to give you one example that we already mentioned early, sand or quartz, silicon dioxide. So silicon dioxide, which is mostly used for making glass. So this material could be in both states, could be in both structures. It could be crystalline structure, or it could have an amorphous structure. What make the change from the crystalline to an amorphous? Also, it is the heat or the thermal treatment. So by thermal treatment to high temperature, so we can also change the structure of material from crystalline to a non-crystalline materials. So this property is very important for reactive materials. It is a very vast and very deep topic about crystallography, so we're not going to study this in details, but just keep in mind that the two different materials, it's the same chemical composition, silicon dioxide, but here it is crystalline, here it is amorphous or glassy or non-crystalline. So they have completely different properties. Reactivity is different. This one is a non-reactive, and this one is reactive material when it is in a powder state or in a powdered material. So now we have seen the state of the materials. We will move now to the material science and materials engineering or materials technology. What's the difference between these two and what we mean by a multidisciplinary approach, and why materials are called multidisciplinary. Why to study materials you need to go for multidisciplinary approach. So you can see here, material science, the box of material science here is like a curve or like an intersection of different arrows coming from different fields and different disciplines. So you can see the engineering, and in two ways. You can see also the chemistry. You can also see the physics. This is just to name three major disciplines without naming other sub-disciplines. So to study materials science, you need to refer to the physics, you need to refer to chemistry, you need also to refer to engineering. And also for engineering, you need material science, you need to study physics, you need also to have a good background in chemistry. So you can see this is why we call it multidisciplinary approach, because it involves different disciplines, multidisciplinary. So it involves disciplines related to physics, related to chemistry, related to material science. So the bottom line, in order to understand properly material science and materials engineering, you need to have a solid background, or you need to have a strong background in physics and chemistry, at least to mention these two major disciplines. And you can see here much more details about the involvement of different disciplines in material science and engineering. So you can see the interconnection or the interaction between material science and crystallography, bioenvironmental science, chemical engineering and chemical processing, mechanical, electrical, civil engineering, architectural product design, engineering design, chemistry and biochemistry, physics and solid state physics, and also other disciplines related to metallurgy. So you can see this is why we call it a multidisciplinary approach. Without knowing or without having some background from these major disciplines and areas, you cannot understand materials science. And this is simply why we request as a prerequisite to take this course to have already taken physics and chemistry. And also, of course, some basic knowledge about mechanics. So this is what justify the multidisciplinary approach, because you need knowledge and background from different disciplines. So material science combines many areas of science. So many areas of science are needed to be used when you study material science, including, of course, chemistry, physics, engineering, to make better, more useful and more economical and efficient stuff. So this is for the purpose of what? Why we need all this knowledge from these different disciplines and different areas, because we want to produce material that is useful, so it can fulfill the function that is designed for, and also it should be economical material, it should not be too much expensive, and also it should be efficient when it is used for specific purpose, so it should be efficient in doing the role and playing the role that is designed and used for. The term of material science and engineering, it's not really new, but it was first used in 1960. But before this period, it was mostly called metallurgy or metallurgical or ceramic engineering, because at that time, most of the materials used were dominated by metals. So this is why they were saying mostly metallurgy. which is the science of studying metals. Or they were using, of course, pottery and other ceramic materials, so they were saying ceramic engineering. So by introducing the polymers, so the wording of metallurgy or ceramic engineering does not fit, does not include all these science. So this is why they moved to the most generic and the most authentic wording, which is material science and engineering. So it's almost always after the war. So people start discovering more and making more advanced, more research in order, of course, to compensate and to rebuild what has been destroyed during the war. And this is what happened also after the Second World War. So after the Second World War, so many sectors, industrial sector has been growing up. And of course, when you have a sector, industrial sector growing up, that means there is a research behind, which is of course serving this development in this specific industrial sector. So after the Second World War, many new disciplines and new fields have been emerging, especially polymer chemistry, solid state physics, and physical chemistry have been emerging from, of course, traditional fields. When we say materials, so usually this word is referring to 5 major types of structural materials. Okay. And in addition, of course, to the electronic materials. So these are structural materials because they are used to make different types of structure. So this is why we call them structural materials. And we will discuss later on these 5 materials. But also we add to that electronic materials, which is, of course, semiconductors. We will discuss these types of materials later on in the coming slides. But the word science, it refers to the fundamental of structure, classification, and properties of the material. While the word of engineering describes mainly the aspect of selection, how you select the material based on what are the criteria used to select which material you have to use from these 5 major types or from the different types of material within the same category. So the selection is always based on the principle that you have to choose the right material for the right application or the right job. So what is the meaning of science, material science and materials engineering? So just to make things very simple, so in science, what we look for the truth. We always need to explain the reason why the sky is blue. So science is looking to explain, looking for the truth, looking for reason why. So the question answered in science is mostly why, which is opposite to engineering. In engineering, as we will see later on, we don't often ask why, but we often ask how you design, how you make it, how you increase or how you enhance the performance of the material. So material science is a study of the stuff or the material itself. So we are studying the material itself, the composition, the properties, and and finding the why. Material science is the study of solid matter, organic and inorganic, and depicts how these materials are classified. So science want to know why, providing explanation for observation about the natural world. Technology or engineering is mostly focusing on knowing how you design it, how you create it, how you provide it, how you make it better. So engineering is mostly about creativity, originality, creating original design, creating original materials, original properties, and innovation. Propose solution. So there are problems the society is facing or specific industry is facing. So engineering and technology is here to propose a solution for human adaptation to the environment, because human is living in different environment, from extremely cold to extremely hot. And in this range of different environment and different temperature and different aggressivity of the environment, materials behave in a different way. So in engineering, of course, you got to adapt the behavior of the material depending on the environmental conditions. So in one word or in one short sentence, we can say that material science is investigating the relationship that exists between the structure of the material itself and the properties of the material. So finding out the relationship or the interrelationship between the structure of the material and the properties. While in the engineering, materials engineering, so based on what science is presuming or what science is characterizing as or finding out as a relationship between structure and the properties of materials. So materials engineering will use these relationship between structure and properties for correlation and for designing engineering structure of the material and producing predetermined set of properties. So based on this, we want to produce a material that has this and this and that properties. So predetermined or tailored properties. And this could be done only by knowing this relationship between the structure and the properties of materials. That is, of course, mostly studied in materials science. So you can see that the relationship materials science and materials engineering, they are not separate. There is no border between these two major disciplines. They are interrelated, interconnected. They cannot work separately. They have to work together because each one is serving the other in a different ways, you know. So let's briefly look at this chart here. You can see science originate in questions about the nature, the natural world. So mostly questioning. Applies methods of inquiry. Propose explanation. So you can see we focus more on explaining, explanation in science. You have a phenomenon, so you want to explain it. And then, of course, from this, it will raise new questions also, and you apply the same principles of inquiry and propose new explanations for any new questions that is raised. And you apply this to social application of explanation and finding solution. Personal action based on explanation and solution. For technology or engineering, so originate in problems of human adaptation in the environment. So you have problems, societies facing problems, industries facing problems, and so on. And as a materials engineer, so you need to apply problem-solving strategies in order to find out solutions to those problems that are identified. So you propose solutions for the identified problems that are facing human being to adapt with the environment. And from that, of course, you always will generate or new problems will arise, and again you will apply the same principle of problem solving and propose new solutions. But at the end of the day, you can see that they are both materials engineering and material science, and both are looking for social applications of explanation and solution. Whatever it is explained here and whatever solution is are found here. So of course both are emerging or both are heading towards social applications. Of course, this could be characterized in terms of adapting homes and houses and centers or whatever for social applications or other types of applications. So at the end, we can say that between material science and materials engineering, there is no boundary, there is no frontier. They are mixed together. It is true that material science is focusing on explanation, and materials engineering, it is focusing more on designing, creativity and originality and finding out solutions. But at the end, they are not really competing each other. They are completing each other. And usually we cannot find out exactly where, let's say, where materials science is ending and where materials engineering is starting or beginning, because they are interconnected and interrelated. So the difference between science and engineering or technology is, it is important to know that they are fundamentally different from each other, but they are complementing each other. They are not competing, they are working together, they are serving each other. Now, if we look to traditional engineers and moderns and engineer, so let's say traditional engineers were mostly focusing only on the technology of construction materials with no or very little knowledge of material science, because material science was not that much developed and that much adapted. So traditional civil engineers, they were mostly focusing on how to construct. But the introduction of new materials in construction, you can see now that every year, or let's say every lapse of time, we have new materials that are coming in the market and used in the construction industry. And of course, this necessitates the need of knowledge on materials science in order to understand the behavior of this material and how they can be integrated in the process of construction in a specific environment. So why studying materials science and materials engineering? Of course, I think after all what we have said, so you can get at least a very summarized and a very clear idea why you need to study materials science and materials engineering. Materials engineering, as an engineer, you are exposed to design problems involving materials. So either you are a civil engineer or you are an architectural engineer. Of course, the ultimate target is to design different structures, design different buildings. And to design this building or this structure will be built with what? With materials, of course. So how you can design something to be built with materials and you don't know anything about these materials? So this is the main target. You're designing types of structure that will be built with materials, so you need to understand, or you need to have minimum knowledge about these materials. So material scientists and engineers are specialists who are totally involved in the investigation and design of materials. Materials problem is one of the selection of the right material, selecting the right material from many thousands that are available. So your job as an engineer, once you design your structure, you have to choose which materials you have to recommend to be used for the construction. Because in some applications, you have a large variety of materials that could be used in that specific application. So which material you have to select? So this is, of course, a matter of knowing the materials. If you don't know, if you don't have enough background, enough knowledge about the materials, of course, you cannot select the right material for the right application from a large variety of materials available. So this is why you need to refer to some criteria on how you can take the decision. So usually we have some very common criteria that are used for selecting the material, the right material to be used for the right application. So one of the criteria is in-service conditions. It's not after manufacturing conditions or behavior, but how this material, if it is used here in Oman or there or in any other Gulf country or in Europe or North America, how it will behave depending on the conditions, the actual conditions. So in service conditions, how the material will behave will indicate and will dictate what are the properties needed for this material. Because a material that is used in a hot climate might have different properties than a material that is supposed to be used in a cold climate. Sometimes you need to trade off one characteristics for another. So kind of trading off. Deterioration of materials properties that may occur during service operation. This material is used for specific application under environmental conditions, specific environmental conditions. So you need to predict and you need to understand how this material will react with its environment, how it will interact, whether it will be deteriorated after a certain time due to the environmental conditions, and therefore maybe the properties of this material will be lost or will be reduced. So this also needs to be fully understood. Also, we should never forget the economical aspect. So economy also is always part of the analysis. And this is why, of course, as an engineer, always you have to take or you have to study a course of engineering economics, because choosing the material, of course, you have to include the economic factor. You cannot choose any material, of course, even if all the materials, they fulfill the requirement and they fulfill the properties required. But at the end, of course, you have also to include the price. What is the cost of the finished product? Because the cost of each product will, of course, affect the cost of the whole project. And you need, of course, to make your project economical as much as possible. So I think after this, you understood that whether you are a civil engineer or you are an architectural engineer, of course, you need to study materials and you need to understand the behavior of materials, because we have like somehow like an aptitude of some students, especially architectural engineer. They are saying we don't need to study this course. We don't need to study construction materials. This is mostly for civil engineers, for civil engineer student. This is completely false. So if we look at materials nowadays, or materials in the past and materials nowadays, of course, there is tremendous change in the quality and the durability of the materials, in the performance of the material. The car of the 1950 was more durable, yes, was larger, yes, was heavy, yes, but also it was not designed for to exceed certain limit of speed. Cannot really exceed something like 120 kilometers per hour, which is now something like the normal speed for any car. So nowadays the weight of the car has been reduced, and if you reduce the weight of the car, of course, you can enhance or increase the speed. So also the sheet metal used for building the body of the car is now thinner than what was in the 1950 and before or after, where this sheet was much thicker, but of course it was much stronger, of course. Now in the car you can find many plastics. Aluminium are extensively used, replacing some parts of metals, and this of course will reduce, of course, the weight and the price of the car also. So this is just in the car industry, but also in other industries like biomedicine and so on. So of course many other biomedical materials are invented and are used for of course for the purpose of making the life of human more comfortable. Just have a look to these pictures. We will finish with this. So you can see the difference between these two different models of the cars of yesterday, the old car and the new car. Let's say they are the same model, but you can see the changes that has occurred. So just reflect about the changes that you can observe here and write down and note what changes could occur here. So you can see the change in the design, change in the style, change in, of course, the weight, change in the type of materials used. Here mostly metals, but here you can see some plastic. And therefore, of course, it will change the properties of this car compared to this one. So same thing here, of course. So changes are mostly related to what? To the materials used. And when you change the material, of course, you change the performance of the whole structure. If we consider, of course, the car as structure, of course, and the car, of course, it is type of structure. Structure is not only a building. We'll stop here, and in next recording, we'll discuss how you select the material and what is the process used to select the materials.